How do publishing houses publish books? Well, eventually they come up with a first edition of a book, let's say this book on databases. Then, over time, they collect typos, errors, changes that should be applied to that book. That is collected in a change list. So, for example, this could be a spelling error on page 23, there's another error on page 345, and another error on page 77. Eventually that list gets so long that the publishers decide to come up with a second edition of the book. The second edition collects those changes and merges the two, adds the two into a second edition of that book. So they publish the second edition and they start collecting changes all over again. So now they have an empty list, but over time more typos occur, like camera was not spelled correctly, big data should actually be big data, and so forth. There's a new chapter on tools that should be integrated. So eventually again they merge the two, the second edition and those changes, into a third edition of the book. And again they start collecting changes. So more spelling errors and so forth. This principle of collecting the changes in a separate list, in a separate structure, and then eventually merging the changes with the existing version is called differential files in data management. It's exactly the same idea as publishing books. So on differential files, we have a current edition of the file and we have the changes we actually need to apply to that file. So all changes we want to apply are collected in this separate file, the diff file for short, or differential file. Here we add all the inserts, updates and delete operations, collect all the information on what has changed. The current edition is read-only, like a book. If you have a book, you can't change it. It's out, it's in the bookstores, no way to change it anymore. So this is basically read-only. We do not apply any changes. Just eventually, we merge the diff file and the existing current edition into a new version of the read-only file. That is the idea of differential files. And you may already recognize that if you watched my previous videos. This is another instance, yet another instance of the batch patterns. Rather than applying those changes individually, we apply all of those changes at the same point in time. Therefore, differential files is another instance of the batch pattern. And it's also an instance of the all levels are equal pattern. And this is the reason why this is presented in quotes here. This is a technique that does not only work for files. So this technique has many advantages. One is it may be applied at almost any level. So be it entire databases, it could be that you have a read-only database and collect the changes into a writable database and then you merge them. That's one way of applying that idea of differential files. Or you can do it at the file level. You can do it for indexes. Differential indexing is a topic we will look at later on in more detail. It's very important and there are many interesting structures out there. And you can do that in disk or main memory. It has the same advantages, the same drawbacks in either case. You can apply it at the level of tables. You can apply it at the level of blocks. So whenever you change a block, you write it to the differential file. You write the changed version to the differential file. But you can also apply it at the level of pages. So if the page is the main memory concept of the block, or you can apply it on more fine granular levels like rows in a database. A major advantage of this technique, so what you gain is cheap writes. The writes get cheaper because you collect them in a separate structure. We will see it depends heavily on the physical organization of that structure, but usually that is the effect you see. Then what's also important in practice is the differential file corresponds to an incremental backup. If you did a big backup of the read-only file, if that is your read-only file, and then you collect your changes in the diff file again. If you already did a backup of the read-only file and then you do a backup of the differential file, you have all the data available because The read-only file plus a differential file gives you the current version of the data. So it's totally fine to just do the backup of the differential file. You don't have to do a backup of the read-only file again. This also means the read-only file corresponds to a snapshot of the database with respect to a certain point in time. But basically it is as if you took a picture, a still image of the data at a certain point in time. That's a snapshot of the data, a snapshot of a particular version of the data. Of course, you merge the differential file and the read-only file into a new version. This can be exploited to defragment the blocks on the storage medium. So whatever layout you use, whatever granularity you work on in differential files, you can exploit that to get a more sequential layout. And it's relatively easy to implement. There are some drawbacks. So one is you have expensive reads. Why is reading expensive? Well, in a differential file, if you have your read-only file and you have your differential file. If you read, it's not enough to just read this file. You have to read both of them. So the truth, the most up-to-date version, the current version, is reflected by combining the data from both structures, which means in the worst case you have to look up both of those structures. Again, it depends a lot on the physical organization of the structures, of the internal organization, but on the high level it's important to understand, if you only look at this structure, of course, you won't get the changes, you won't consider the changes that were collected in the differential file. So whenever you query a differential file structure, you have to query both the read-only file and the differential file. Only then you get the most recent version. That is why reads may be expensive. There are additional write costs, so the merge costs need to be amortized. We will look at an example on how the merge works in a moment. There's extra storage space, of course, especially if you organize the differential file on a very coarse granular level, for example on blocks. If for every change you copy the change block to the differential file, that may be expensive. And important to understand is the truth, which means the current version, the most up-to-date version of the data, can be retrieved by looking at the read-only file and possibly multiple diff files. We will see that in a moment, why this is not only a single diff file, but it can be multiple diff files. So let's look at an example. How do the merges actually work in diff files? So in this example, I will be merging read-only files with differential files. And I do that along a timeline. So this is a timeline. On the timeline, we have certain points in time that identify a frame. So this is called frame 1, frame 2, frame 3, and so forth. And within 2 frames, there are certain things happening. So let's look at the time interval between those 2 frames, 0 and frame 1. So what happens here? We have our read-only file. I marked it here. This says this is readable. We can read from that file, but it's not allowed to write to that. That's what this gray W reflects. And we have this read-only file in version 0. At the same time, we are collecting changes in the differential file 0. So what this means is any incoming query has to look at both structures, has to look here and to look here to not miss any changes. That is what queries do, read queries. That's very important. On the other hand, changes only go to this structure. That's what I said before already. Changes go only here. This is the only writable structure. So now how would we come up with a new edition of this file, of the read-only file? Now how do we get to version 1 of that? Well, it's relatively easy. We do that by merging the differential file with the old version, the old edition of this file. So this means, let's go back here, the major change we do is we change this differential file to read-only. We see that when I go to the next slide. So now it's read-only. And what we also have to do is, because we want to be able to handle incoming changes, we create a new diff file. So this is a new diff file number 1, and this is now collecting all the changes. Changes are now routed, are directed to this differential file. Concurrently, we merge the old read-only file of version 0, the old differential file 0, into a new edition of the read-only file in version 1. And you observe already here, this is not readable, this is only writable, which means what's going on here is a merge. This is a merge operation going on. This is a merge. Changes go to this structure, but then the interesting question is what to do with queries, with read operations. Well, what is the current version at any point in time in this time interval between frame 1 and frame 2? Well, actually, as this is not complete and we can't read it, it's set to write only, we have to combine the information from read-only file version 0, read-only diff file version 0, plus the read-write diff file 1. So actually here we have to combine the 3 structures, this, and this, when reading data in this situation. That's very important. So eventually this merge terminates. So eventually we end up with a new version 1 of the read-only file. In that situation we can route incoming queries to that version 1 again. So this may look like that. So here we switch it to read-only and route any incoming queries against this version 1 plus the differential file. Changes again only go here. And of course, then we can also start creating a new merge. So this basically repeats what we saw before. So here the read-only file of version 1 is merged into a new version using the differential file 1, which is now switched to read-only. So again, in this situation, all changes go to the new diff file. We start a new diff file collecting all the changes that are coming in. Whenever you want to query the current state, we have to look at those 3 structures. So the old version 1 of the read-only file, the differential file 1, and the differential file 2. And again, once this merge here is done, once those 2 structures are entirely merged into the new version, we can reroute the queries to consider only this version 2 plus the differential file 2, and so forth. So this is how merging in differential files work. And keep in mind, so once you're done merging the 2 structures here into the new version v2, no one forces you to directly start a new merge. So as any merge operation costs something, the point in time when to start a merge basically has to be balanced with the different costs we have here. And we will see that in the lab and in the exercises. We have costs for reading multiple structures, we have costs for writing. But of course, in any merge here, you read the entire v1 read-only file, which may be very, very big. You read it once, you read the differential file once, and you write the sum of it into a new structure. And these costs have to be balanced with the gains you have by merging them into a new version 2. If you liked this video, don't forget to hit the like button. Thank you. So if you want to see more database videos, be it in English or in German, take a look at my website datenbankenlernen.de. It has a couple of English and German videos. You can also subscribe to my YouTube channel, Jens did, or you look at our website infosys.uni-saarland.de. See you there!